Hello guys, welcome back to the session. This is Trishir, Alva. Welcome to the chemistry session. Welcome to the chemistry session on structure of atom. Structure of atom. So let's start. In the previous session, we got to know that atom is indivisible in nature, and the basic structure of atom. In this session, we will be discussing about Dalton's atomic theory and also the two subatomic particles that were discovered using the discharge tube, that is the protons and electrons, and their masses and charge. So let's start with the session. So firstly, we will start with Dalton's atomic theory. So John Dalton proposed the Dalton's atomic theory. He told that matter was composed by tiny indivisible particles called as matter. Please note down, matter was composed with tiny indivisible particles called atoms, and atom of a given element are identical and possess unique characteristics. Atoms of a given element are identical and possess unique characteristics. Atoms of different elements have different weights and different chemical properties. Atoms of different elements have different weights and chemical properties. Okay, different elements, similar elements we learnt just now, right? Atoms of different elements combine in ratios of simple whole numbers and form compounds. And last one, very important, atoms can neither be created nor be destroyed, Okay, so the Dalton's atomic theory states that matter is composed of tiny indivisible particles called as atoms, and different elements have different atoms of different weights and different chemical properties. Similar elements have similar weights, similar atoms of similar weights and similar chemical properties and possess unique characteristics, and atoms can be neither created nor be destroyed, and atoms of different elements combine to form compounds. Okay, to form compounds. So let's start with the discovery of electron. See, electrons have a unique characteristics. Okay, they possess negative charge. Electrons. So our electrons were discovered by J.J. Thomson. Okay, he took J.J. Thomson. He took a discharge tube. Here it's a perforated cathode, okay, but in terms of electrons it was not a perforated cathode. He took two metal electrodes, that is anode and cathode, and connected to a battery of high voltage, and electrode connected to the negative terminal is called as cathode, positive terminal is called anode, you know that, and the tube was connected to a vacuum pump for controlling the pressure inside the discharge tube, and air was introduced into the discharge tube. Pressure of air was maintained at 760 mm of mercury, that is 1 atmospheric pressure, and voltage was somewhat 10,000 volts. Air being a poor conductor of electricity, it didn't conduct electricity. The gas pressure was then slowly reduced to 1 mm of mercury with voltage being at 10,000 volts. What did this do? The electric current started to flow through the air. That is, it ionized the gas, that is the air. It ionized the air, and light was also emitted inside the tube. Emission of light then ceased when the pressure inside the tube was reduced to 0.001 mmHg or mercury, and one end of the discharge tube opposite to that of cathode electrode started glowing with faint greenish light. The process is known as fluorescence. So, see, I read out the thing, right? Process. See, what they did is they just had a glass tube, discharge tube, which had two electrodes, the positive electrode and negative electrode. Positive electrode is called anode, negative electrode is cathode, and it was connected to a vacuum pump. And when they introduced air into it at 760 mm, 1 atmospheric pressure, the normal pressure, okay, they started to flow at 10,000 volts, nothing happened. The electricity didn't flow through the air. When he reduced the pressure to 1 mm of mercury, then surprisingly the electricity started flowing in the air. How come this is possible? What happened is the J.J. Thomson just ionized the gas by reducing the pressure and increasing the voltage of electricity. So, this process of ionization, because of this process of ionization, the zinc sulfide screen, which is here, zinc sulfide screen, it started emitting some green light, which marked the presence of electrons. So, nothing but ionized gas, okay, ionized air. So, when electricity started flowing, the negative charges then hit the zinc sulfide screen. This is the zinc sulfide screen, okay, and then this led to the presence of discovery of electrons. Okay. So, we will learn the characteristics of electrons or cathode rays. This is anode rays discharge tube, that time it was cathode rays. It was not perforated in terms of electrons, okay. It was not perforated cathode, it was normal cathode. So, yeah, ionized gas. The cathode rays always traveled in straight lines, okay. Properties: straight lines, easily penetrate through metallic foils. Oh no, wait. Easily penetrate through foils, right? And when the cathode rays were focused on the thin metallic foils, the metallic foils got heated up. It's pretty simple. And cathode rays consists of material particles. Material particles were present. This was proved by keeping a paddle wheel in front of cathode rays. When cathode rays were emitted towards the paddle wheel started moving. Okay, and cathode rays consist of negatively charged particles. Negative particles. Okay, negative charge. Okay, therefore it's represented like E minus. Okay, these were the characteristics and the discovery of electrons. And now we'll discuss the discovery of protons with help of anode rays discharge tube. E. Goldstein was the one who discovered protons. Okay, protons. So what he did is, he also used the same discharge tube but a perforated cathode, okay, instead of a normal cathode, and he used hydrogen gas instead of normal air. He used hydrogen gas. What happened? On applying 10,000 volts of electricity and low pressure, new types of rays were observed. new types of rays were observed, and these rays were found to move away from anode and passed through the perforated cathode. See, that time what happened is the rays were moving through to the anode. The cathode rays were moving to the anode, and here anode rays are moving towards the cathode through the perforated cathode, and the green light was emitted because of the zinc sulfide screen. Okay, these subatomic particles are termed as electrons. See, this is nothing but the same experiment. They took hydrogen instead of normal air, and they observed that from the anode the certain rays were emitted and they were moving towards the perforated cathode and then hit the zinc sulfide screen. This was then coined the term as protons. And characteristics, they also travel in straight line. They also consist of material particles, but they are positively charged. That's all. Positively charged. Very simple. Okay. So, using the discharge tube experiment, we got to know about the discovery of electrons and protons, right? See, instead of perforated cathode, they used a normal cathode in the cathode rays discharge tube experiment, whereas here they have used perforated cathode. And in the anode rays experiment, they used normal air instead of hydrogen, whereas, in cathode rays they have used normal air instead of hydrogen, whereas in this experiment they have used hydrogen, right? Yeah, the same thing, ionization of gas. From the previous experiment, that is cathode ray experiment, the cathode rays moved from the cathode towards the anode, right, and then hit the zinc sulfide screen, which showed the presence of negatively charged particles called electrons. And here the anode rays moved from the anode and then hit the zinc sulfide screen to show the presence of positively charged particles called as protons. So, see, now let's discuss the mass and charge of a proton and an electron. Okay, proton, electron, mass, charge. So, first let's know the mass of an proton. 1 second. Yeah. Yes. So, mass of a proton is 1.672 into 10 to the power minus 27 kg. Minus 27 kg. This is very less. Okay. And charge of a proton is 1.6 into 10 to the power minus 19 coulombs. Coulombs is SI unit of measuring charge. And here mass of an electron is 9.1 into 10 to the power minus 31. 9.1 to 10 to the power minus 31 kg. This is very, very less. Okay. And the charge value is minus 1.6 into 10 to the power minus 19 coulombs. Very simple. So, here plus 1, here it's minus 1. That's all. That's all is the difference. And see, and so 1 second. Yeah, we got to know the mass and charge of proton and electron, right? Now we can conclude that proton is heavier than electron. Okay, and so only, therefore the mass of the atom is mainly concentrated in the nucleus region because protons are present. Okay, protons and neutrons are present. They make up the bulk of the atom. So, in today's session, we learnt about discovery of electrons and protons, properties, and also anode ray experiment. Those are the experiments. Okay, experiments. and mass and charge. Mass and charge of atom. Till then, stay safe, stay healthy, and keep learning. Thank you very much for watching this session. Please like, subscribe, and share the video for more such videos to come up. Thank you very much.